Hello everyone, welcome to our presentation on the manufacturing process of tires. I'm Chitmi Leonara and I'm honored to start this presentation in tire production. Joining me in this are Savanana Tunga, Hiruka Gunawardana and Chamika Ratnasiri. Let's dive into our presentation where we will illuminate the key stages, flow diagram, system boundary, functional unit, input outputs and consequences of tire production. Firstly, I'm here to present an overview of the key stages of tire production, delving into its purpose, how it is done, and the stakeholders. First is the manufacturing process, with the first stage as mixing. In mixing, raw material suppliers, machinery manufacturers, factory workers, technicians, engineers are the stakeholders. They work for the purpose to blend raw rubber and additives to create the rubber compound. To do this, they mix the proper quantity of rubber, natural rubber, synthetic rubber, and various chemicals in a mixture known as Banbury mixture. Then comes the extruding part. Manufacturers of extrusion equipment, factory workers, technicians, engineers are involved to fabricate thread and sidewall components of tire. To do this, they take the fabricated strips and they are passed through a die which convert into various shapes. Then comes the calendaring. Manufacturers of calendaring machinery, technicians, factory workers and engineers are involved to shape the rubber compound into sheets. To do this, thin rubber coated fiber sheets are produced and they are produced by squeezing, reinforcing fiber materials into rubber. Then comes the building part. Technicians, factory workers, engineers assemble the tire components into great tire. The layers of rubber and fabric are placed and pressed together using a tire building machine. Sometimes they use adhesive to increase their bonding capacity. Then comes the curing part, one of the most important stages. In this, factory workers, engineers, chemical suppliers, vulcanize and cure green tires for strength and resilience. To do this, the green tire is poured in a metallic mold, but to stop the chances of sticking of the tire into the mold, they use due to high heat, they use a liquid that is coated into the mold. During the curing of tire is forced against this mold, which results in formation of thread and sidewall pattern of the tire. Then comes the finishing. Technicians, factory workers, engineers, quality inspectors trim the excess rubber, inspect and mark tires. They use a trimming machine to cut the excess rubber, while inspectors check the defects and mark tires for identification. Then the distribution part. The manufacturing stage is over. Now it's the use stage. In this, distributing agencies make sure the product is in market for customers to purchase. To do this, price tires are transported from warehouses to tire dealers and distributors. Then the maintenance. Vehicle owners, tire retailers, mechanics ensure safety and performance and overall longevity of tires. They regularly check tires pressure, tire treads and proper alignment of the tires. So we conclude our discussion on tire maintenance, and it is crucial to shift our focus to the last stage of tire production.
I'm Hiruka Gunawardana and I'll be talking about the final stage. This includes collection and storage of used tires, sorting and inspection, reuse and recycling, and disposal. Let's talk about the first part, collection and storage of used tires. In here, the stakeholders involved are municipal workers, tire retailers, and waste management companies. The purpose of this is to collect and store used up tires so they are ready for mass recycling or disposal. The objective is to store them safely out of the general community's reach. The method of doing this are the vehicles are sent and they collect used up tires from various sources such as business enterprises, commercial sources, or even domestic households. And once the tires are collected, the second stage begins. This is the sorting and inspection part. In here, the stakeholders are municipal workers, waste management companies, and recycling plants. To assess, the purpose of this is to assess all the used tires collected and sort them out for reuse, recycling, or disposal based on their condition. The method of this is that each tire is graded individually, either by hand or usually by machine, and they are based on criteria and they are sorted out into either recycling, reusing, or disposal. And the final part, reusing, recycling, or disposal. The tires which are least produced, least used up, are reused. They are sent to tire retailers where they are repaired and they are resold back to tire retailers as second-hand tires. If they cannot be repaired, they are recycled. They are sent to recycling plants where they are turned into other products and reused. And finally, you got disposal. In areas where recycling is not available, tires are often disposed of. This can happen in landfills or in safe incinerators. The stakeholders involved are municipal workers, waste management companies, and landfills. The purpose of this is to get rid of all the used tires and either send it back to the community as different products or safely dispose of it. The methods vary from company to company, but it usually includes taking tires from landfills and then assessing them and either recycling, reusing, or disposing them safely.
I am Savin Ranatunga and I will be in task 2 about mainly the key stages of the manufacturing process of how these inputs can make a tire and the system boundary, what is our system boundary in the manufacturing process, and about the functional unit and the benefits of functional unit for the sustainability comparisons and how it can be used to compare sustainability among different type products. As we come to our flow chart, the collection of raw rubber extracting metal ores for the wires is the first key step of tire manufacturing process. The next is the compound preparation and creating components for the desired tire type containing all the required properties. Next, making a rubber compound by mixing process, adding the different types of rubber, chemicals and pigments to the compound mixture. Along with that, sheets of rubber binded with rubber sheets using calendaring machine and threads of wire in a circular shape as bead wires. Then assembling the bead wires, fabrics and rubber sheets in a drum to build a green tire. Then this green tire in the curing process is applied under high pressure to get the desired texture and density, also known as the vulcanization process. Then an inspection process is carried out to analyze possible defects in the outline of the tire. After that, a quality control test making the tire compliant with the company and governmental policies. Then packaging and distributing tires for the market finally. Then we come to our system boundary. What is a system boundary? We define the system boundary as an outline of the processes in a system which can or cannot be altered. A system boundary can be considered for a single process or a multi-process. For example, I will be taking the packaging and distribution multi-step process. So, when considering some criteria in the packaging and distribution, which can be considered in the packaging of the finished tire and distributing them among the companies or to the logistics teams by the company, which can be altered by the production or the manufacturing team of the company. But the packaging policies and distribution systems in the logistics companies cannot be altered by the company manufacturers. So a part of it is excluded in the system boundary. Moving on to our functional unit. What is a functional unit? Well, a functional unit can be considered as a measure that is used to evaluate the performance or an output of a production process. In tire process, it quantifies the performance or an output of the tire production process. Benefits of a functional unit for sustainability comparisons can be categorized into many parts. Essentially, for comparing impacts of similar products across brands, evaluating environmental, social, economic effects per function, aids to consumer and decision making, emphasizing direct impact and product quality. Functional units also align with the complete life cycle of a product, from the creation to the disposal. Functional units can be used to compare sustainability among different tire products. It can be determined per tire, per ton of rubber, and per kilometer run through this tire. These units can be used to compare the impacts on life cycle considerations, emission considerations, consumer relevance, comparison ease, production differentiation. Now we will be going to task 3, which will be done by Cham.
Thank you, sir. My presentation will be on task 3, the input and output during the manufacturing process and division on input as renewable and non-renewable sources. As here, machinery is used in each manufacturing stage. Electricity is a major energy source used for the processes. For the mixing process, the natural rubber extract from rubber trees water and electricity as renewable sources. As the non-renewable, the synthetics rubber produced in laboratories, chemical additives, carbon, pigment, compounds and fuel or non-renewable electricity sources. Through this process, the mixing rubber compound and the waste materials of reduce also the considers as an output. For milling an input of electricity and water as the renewable sources and fuel rubber compounds electricity as non-renewable sources. After the process is over, a refined rubber compound and other waste materials are formed. In the extruding process, source of electricity and water are considered renewable, marking rubber compounds, fuel and some electricity sources as non-renewable sources, giving the process output as extract, rubber compound and waste materials. In the calendaring process, the renewable input are electricity and water. The non-renewable input are fuel, rubber compounds and electricity, making the output the fabricate rubber sheet and other waste materials. The tire building process, the non-renewable input and non-renewable input are the rubber compounds, steel belts and electricity and fuel. The output are green tire and the waste received. For the curing process, rubber compound, chemical additives, heat and pressure system, making vulcanized tire and waste material along with it. For the tire finishing is the input are the vulcanized tire and the output are labeled finished tire. The next part of our presentation will be carried out by our next team member, Hiruka.
Thank you, Charmika. I'm Hiruka Gunadana, and I'll be exploring the various environmental, social, and economic consequences of the tire production process for the final part of this presentation. The following table describes in detail each aspect of the manufacturing process, but I'll try to provide a brief overview as well. The process starts with the mixing of raw materials. The gathering of raw materials can cause resource depletion. This step has high energy requirements, and it can also provide toxic emissions in the form of VOCs, also known as volatile organic compounds. Furthermore, the quality of employee working conditions are also a matter of concern. Employees are often underpaid and overworked. And finally, the risk of impurities contaminating an entire batch and causing it to become unusable is also present. That will cause a significant loss in profit. The next few steps, milling, extrusion, calendaring, also have similar negative aspects. All the machines in those steps have high energy requirements, and the extrusion process also produces solid waste in the form of tire scraps. The working conditions and the work exploitation is also a matter of concern here as well. Employees are often underpaid and overworked. There is also the risk of workers losing their jobs to cheaper automated labor. Furthermore, again, the risk of impurities and contamination of batches causing them to be rejected is also present. The curing process has several harmful effects, as it includes hazardous chemicals, and emissions are also produced, VOCs or volatile organic compounds. The presence of hazardous chemicals put workers at risk, and the disposal of said chemicals after the process is done will usually incur additional costs from the company, in addition to the normal maintenance cost and the operation cost of the machines. And the final part of the process, the finishing, it also has several environmental concerns. For example, finished tires, after they are tested, they need to be packaged, and improper disposal of this package will cause pollution. The risk of workers being underpaid and working overtime completing these packages is also present. Furthermore, again, parts of the tire could be tested and they could become faulty. Then the entire tire has to be thrown out. This, if it happens often enough, will cause a significant impact in profit.
In conclusion, our exploration of sustainable engineering in the tire production has unveiled a comprehensive understanding of the life cycle stages, manufacturing processes, and integrate the balance of inputs and outputs. From the extraction of raw materials to the final product, we witness the integration web of interconnected stages that contribute to the life cycle of a tire. It is clear that adapting to eco-friendly materials, energy-efficient processes, and recycling initiatives can significantly reduce the ecological footprint of the tire production. Examining these inputs and outputs throughout these stages, we recognize the importance of responsible resource management. Striking out a balance between raw material extraction, energy consumption, and waste generation is crucial for ensuring a sustainable approach of tire manufacturing. It is evident that tire production can be a catalyst for positive change. By integrating innovative technologies, embracing circular economy principles, and fostering a holistic approach, we can not only mitigate the negative consequences but also pave the way for a more sustainable future in the tire manufacturing industry.